Hey everybody, I'm going to go over the 3-1 Math Excel now. So most of this is just solving a system by graphing, and you need the graph and solution. So most of these have two parts. The first couple are like real easy because they're already solved for y, and so we just want to graph using the y-intercept and the slope. So remember, if it's y equal mx plus b, m is the slope and b is the y-intercept, and so we always start with the y-intercept and then go from there. Like for this one, both of the y-intercepts are 2, but on the top one the slope was 1, and this one the slope was -1. And so I just had to graph it. I used the pop-out window and I clicked on the line and then used 0, 2, and then I just used my knowledge of this one being up 1, right 1, and this one being down 1, right 1. I'm not really going to get into all the algebra part because most of this you should already know from Algebra 1. If you need more individual help, I can definitely do that. But this is just basically like graphing two lines, then see where they cross on Math Excel, and you get 2, 4 for that one. Now the next one says it has two equations, but they're not solved for y. And sometimes, like, you may want to do different division or multiplication, just different manipulation of it to see what you have. So for the first equation, I have 2x plus 4y equal 4. I decided, because all of them are even numbers, to divide by 2, so I get x plus 2y equal 2. And then I just start solving for y, moving the x over, so I subtract, dividing everything by 2, so I get -1/2 x plus 1. This one is the x plus y equal 3, and so I just subtracted x over here, and so then I just graphed it. I said, okay, well, this is where 0, 1 is, and then I went down 1, right 2, graph. This one was where 0, 3 is, and so then I went down 1, right 1, graph. And they crossed at 4, -1. Then for this example, you have a vertical line and a horizontal line. It was x equal 4, y equal 2, so you get 4, 2. That's probably the easiest type problem. Just remember that the x equals is a vertical line and a y equal is a horizontal line. Now it says solve by graphing or use a table. So I've got these two. I've got -x minus 2y equal 4, so I just started adding x and divide by -2, and I got y equal -1/2 x minus 2. On the other one, I have 2x plus y equal 1, so then I have y equal -2x plus 1. So my slopes are different. They're not perpendicular because it's not the negative reciprocal or opposite reciprocal, as we say. On this one, a little side note, be careful when you're graphing, since your scale factor would be 0.5. So basically, when you're graphing, you've got 0 and then a space and then you got 1. So that little space is the 0.5. 0, 0.5, 1, 1.5, 2, etc. So just be careful about that. I did use 0 as a point just because that's the easiest. If it's 0, then this one's -2 and this one's 1. So that's extremely fast whenever you can use 0. And then I just tried a random number, 1.5, which is the same as 3/2. I got that they were different. And then I used 2, and both were -3. And so because of that, you get 2, -3 for your answer. Okay, on your next problem, it says a store start over on this one. A store sells small notebooks for $8 and large notebooks for $10. If a student buys 6 notebooks and spends $56, how much of each did he buy? So I worked it myself thinking, okay, if it's 56 and I've got 8, then I probably need to do 8 times 2 to get 16, and then I do 10 times 4 to get 40. So this was just completely me just thinking, what could it be? It must end with a 6, the money, because we got, multiple of 10 for this. So this had to end with a 6. And so I just figured it out. And I got, okay, well, yeah, 2 plus 4 is 6 notebooks. That fits that criteria. And 16 plus 40 is 56. So I did that even without an equation. Now, in the view and example, they showed you can say this is 8x plus 10y is 56, and x plus y is 6. So, like, this one is just how many items you have. And this, like, the price is in front on the price equation. And this is what I would consider, like, the number of items equation. And since there were 6 notebooks, I did x plus y equals 6. So from there, I took my first equation, I subtracted 8x, I divided. At first, I had it in fraction form, like I copied that down here. Then I decided it's going to be easier to work with decimals. So I said negative 0.8x plus 5.6. But those are equivalent. And then for the other one, x plus y equals 6, so y equal negative x plus 6. So for my table, for this method, I had the number of small, x goes from 0 to 6, and then the y for this one or for that one. So when I plugged in a 0, I got 5.6 and I got 6. They don't match, so I have to go to the next one. When I plug a 1 in, I get negative 0.8, so 5.6 minus 0.8 is 4.8, but on this one I got 5. And then when there were 2 small, then this turned into 4 and this was 4, and so then I could stop. So 2, 4 is my intersection point, which means I had 2 small notebooks and 4 large notebooks. So if you want to use the equations, you can, or if you want to do your own method, again, it's algebra, so there's more than one way to do it. Now, with this question, it says, without graphing, classify the following system as independent, dependent, or inconsistent. So just as a quick review, independent means the slopes are different and there's one solution. Like most equations are going to have one solution. But dependent is if the slopes are equal and the y-intercepts are equal. That means it's really the same line, and so we call that infinitely many. So that's called dependent. And then inconsistent is if the slopes are equal and the y-intercepts are different, there's no solution since there's parallel lines. So keep that in mind as you're doing these. For the first one, we have 4x minus y equal 4, and we have 8x minus 2y equal 8. Well, I just divided these by 2, and I got the exact same equation. So they're the same, so then it's dependent for mine. Remember, your numbers could be different. They could jumble and be in any order. So you need to just know how to do these. The next one, I have 9y minus 3x equal 21. All of those are divisible by 3. So I got 3y minus x equals 7. And on this one, 15y equal 5x minus 35. All those end in 5, so I divided by 5, and I got 3y minus x is negative 7. So one positive, one negative. I didn't even bother getting the slope, but I know they have the same slope, and they have the different y-intercept because the numbers are different. There's no solution, so it's called inconsistent. So to get the slope, we'd say 3y minus x equals 7, 3y equal x plus 7, y equal 1/3 x plus 7/3. And then I'd get 1/3 for the other one also. Again, not worth really getting the slope. Just knowing that the left side of the equation is the same is enough. These numbers are different, and so it's inconsistent because they'd be parallel lines. The next one we have 6y minus 2x equal 8. I divided by 2 to get this, 3y minus x equal 4. Then on this one, it's in a little bit different format. I have 9y equal 3x minus 12. So my first step was actually just make it look alike. So I've got 9y minus 3x equal negative 12. Then I divided by 3 to every single term, and I got 3y minus x is negative 4. Then I noticed the left is the same, the right is different, so it's inconsistent. So that's what happens when they are parallel lines. Okay, then this one is the longest question. It's 3.117. It's talking about life expectancy at birth from 1970, someone born that year to the year 2000. And so they had a big table with years, men and women, all the data. Then they said let x be the number of years since 1970. And so then I put 0, 5, 10, 15, 20, 25, 30. And then it asked, what is the linear model for men? So since I knew I was going to record this, I actually saved this document so I don't have to retype it. I'm going to go to document. Actually, I'm going to go to recent. And then I have this 3.1.17. And I already worked it out earlier, so basically what I have is, let me actually close this table. I started with this, which I'll show you how to do on the 1.1. Basically, I put in an X there and put my data. So for 0, it was 69.4, then it was 71.1, etc. I called this M for men, and I called this one W for women. Okay, so you basically just type your data in. Then once your data is in, then you just go to menu, statistics, stat calculations, and linear regression. And that's when for the X list you would do X, and the Y list you'd do M for when it was men. And then it automatically saves your equation. Why I'm bringing this up is because when you do this, you can actually open a new tab or open a new page. So you do Control plus. Well, Control Doc is plus page. And when you do that, it had my equations in here. And all I had to do was do the check boxes. See how detailed that is? I didn't type that. It automatically carried it over. Same thing for this one. And so then all I had to do was say, make this out to 100, make this out to 100, and find the intersection. So I did menu, statistics, stat calculations. 3 was linear regression in the MX plus B format. The question also says round to 3 places using X, well, round to 3 places. And for the men, I had to use X comma M, and I got this. And for the women, I had to use X and W, and so I got that. Then it asks you, in what year will they be equal? So then I added a page, I graphed it, made the check boxes. They were automatically there from regression. And I got the 94, 90 basically. Now, it wants to know in what year would they be equal. So it's not the year 94. That doesn't make sense. So our X was 0 with 1970, and then we add 94 and we get 2064. So in the year 2064, the life expectancy for men and women would be the same. Notice on all these, women had a longer lifespan, but then it gets closer and closer together. And it's not necessarily linear. Like, it's not always adding the same amount. These are regression lines. So again, as how I set it up without getting all the data points, I would start with list and spreadsheet. Okay, so start with list and spreadsheet. So then I put X up top, then I put M for men. I'm hitting tab in between. Then I put W for women. Now everybody's numbers are going to be different, so you really don't have to save your document. They're going to change all the time, like all the numbers. But just put in 2 ordered pairs, 0 and 5, and 69.4. Whoops, that just messed up. 69.4 and 71.1. And then 75.3 and 77.7. Okay, I'm not going to type in all the data, but just to show you again, go over to the side somewhere. I don't care if it's E1 or F1, whatever. Do menu, statistics, stat calculations, and then linear regression, MX plus B. And this is where I either type X or I can go to the right and choose X. And same thing for Y list. So in this one I want men. It's going to save it to F1. So there it is. Now with only having 2 ordered pairs, it's not going to give me many decimal places. And it is going to be perfect regression. So it'd be 1 or -1. And if it's positive slope, it'd be 1. Then I'd go over here to this one. I'd go menu, statistics, stat calculations, linear. This time say X and say women. And it's going to save it to F2. So then I get that. And again, I got perfect regression because I only used the 2 ordered pairs. So at this step, I only have 1.1 there. And I go Control Doc to add a page. Then I want a graph. And it starts me on F3, but if I go up, oops. Okay, I just had to hit escape, control in this. If I went up 1, I hit enter, and it now has that as a check mark. And then I go to this one, hit enter, See, I'm just pressing enter right there. And then it shows up as a check mark for that. Then it's like, oh, it didn't do anything. Yeah, it did. You can double click this, put 100, and so forth. Manipulate this. If you don't like double clicking, you could go to menu, window, and then settings, and just adjust all these numbers. Now for mine, because I only use 2 points, my answer is not really going to make sense. It's going to be somewhere over here, which really doesn't make sense. Like, oh, before 1970 it was equal. But again, it's going to be over on the right. So make sure you use all your data points, because if you only use a couple, your answer is going to be wrong. Okay, so again, that's the longest problem. Now for extra practice A, this is back to like the simplest type. You have y equal 5x plus 4 and negative 2x minus 3. Graph it. It's already in terms of y equal, like slope-intercept form, and you get negative 1, negative 1. Then for this one, extra practice B, you have 2x plus 2x plus y minus 5 equals 0. And so I solve that for y. And you have 8x plus 4y equal 12. So on that one, I moved my 8x over, divided everything by 4. And so now these have the same slope, so they're parallel lines, and they are different y-intercepts. So if they're parallel, with different y-int, that means there'd be no solution. Then for our last one, I've got y minus 3x equal 2, so y equal 3x plus 2. And I've got 2y minus 6x equal 4, so now I divide by 2, so I get y equal 3x plus 2. They are exactly the same. They're the same line, so you only graph it once, and there's infinitely many solutions. All right, so that would be the end of this video. Have a good day.